So I'm looking at a word problem with solving the length of a square with a diagonal. So this problem that I was sent was from a student who I tutor, and it's about a Japanese version of chess, where you use a square board and it's covered with small squares. Then just to set that up, if you have a square board, you're going to have one big square, and we don't know the size of this square. But this square is covered in small little squares, and each of those little squares has a length of 2. And we know because they're squares that all the lengths are going to be the same side. So what we want to do is figure out the area of the big rectangle square and divide by the area of the small square. To do that, we need to solve for this side length. So when we're going to set this up with that piece of information about the diagonal has a size of 5,000, or the root of 5,000, and we still don't know these sides. But by putting the diagonal in the square, we do have a right angle triangle, and that is our hypotenuse. So we can use the formula a squared plus b squared equals c squared, replace some values. So x squared plus x squared equals the root of 5,000, and this is all squared. And then on this left hand side, you can collect like terms. So you're going to get 2x squared, because there's 2 of them. And when you square a square root, that cancels. So that's going to equal 5,000, because again, this is canceling itself out. So now we want to solve for x by dividing both sides by 2. So x squared will equal 2,500, and then we can take the square root of both sides, and x will equal 50. I'm just going to go to the next slide just to have an idea of what we're doing. So the diagonal we are now done with. We've now figured out that each side of our big rectangle is 50. So if we wanted the area of the big square, it's going to equal 50 times 50, which was 2,500, and that would be centimeters squared. Then we want the area of the small little one, which is 2 and 2. So of the small square, so 2 times 2 equals 4 centimeters squared. So now that we have that, we can take the big one, the area total of the big square, divide by the area total of the small square. And when we do that, we'll see 625 squares, the small ones, can fit in the board game. If you watched this far and you found this helpful, please subscribe. If there's any other question I can do for you, please just leave me a comment. Thank you for watching.